long way up there. I had prepared remarks for much longer than this. I'm trying to keep this short. Actually, before I begin the presentation for the Golden Omega Award, I'd like to call Simon Rowland up, who has something that he would like to address you. Simon?
Thank you. Thanks very much. I'm one of those people who just turned up to this event and enjoyed the hospitality and the superb organisation. And that is because of the leadership of the conference chair, right? And anyone who's seen the level of energy and the enthusiasm, the preparation, which has gone on for years, right, at this event, I'd like to say we all appreciate it very much. So as a token, if you'd like to come up.
Oh my goodness.
Just thank you from us all
Thank
for
you.
your fantastic contributions. Really appreciate it.
I just want to thank you all for this very much. Thank you.
Well, I have to say that for more than 50 years, the IEEE Dielectrics and Electrical Installation Society and NEMA have bestowed this Golden Omega Award to an outstanding person of science, engineering, education, or industry who's made important contributions to technological progress. Previous recipients have included such giants as Admiral Hyman Rickover, the father of the nuclear submarine; James Van Allen, who discovered the radiation belts around the Earth that bear his name; David Packard, co-founder, president, chairman of the board, and CEO of Hewlett-Packard companies; William Lear, developer of, the famous Learjet; Joseph Engelberger, the father of robotics; Harry Gray, chairman and CEO of United Technologies; Charles Knight, chairman and CEO of Emerson Electric. Recently, Lloyd Trotter, vice chair and vice president and CEO of GE Industrial. And of course, last year's recipient, Theodore Huang, chairman of the TICO Group. That's a pretty interesting group of people who've gotten this award. And if someone were to ask, what was the one characteristic of all these men shared, in addition to their passion and quest for excellence, the answer would clearly be these were men of great vision, men who had the ability to see what the future might be, and men who were not willing to accept the status quo. And tonight, we are pleased to add to this distinguished list of inductees the name of John W. Estey, President, Chief Executive Officer of SNC Electric Company, Chicago, Illinois, and Chairman of the Board and Chief Executive Officer of SNC's operations in Canada, China, Brazil, Mexico, and Europe. John earned his degree in electrical engineering from Queen's University in Kingston, Ontario, after which he left his native Canada, joined the SNC Electric Company nearly 40 years ago. John held numerous responsible positions in the company in the R&D, marketing, and marketing operations, and in June 1988, he was elected President and Chief Operating Officer, and subsequently became SNC CEO in June 1997. Under John's leadership, SNC has become a global provider of equipment, software, and services for electric power services. Today, SNC Electric is recognized throughout the world for its innovation to address challenges facing the world's power grids and thus shaping the future of reliable energy. What also makes John such an ideal awardee for tonight's honor is his longtime commitment to both of tonight's sponsoring organizations. John has served for 16 years on the IEEE Power Engineering Society Governing Board, and is also former chairman and longtime member of the National Electric Manufacturers Association Board of Directors. This type of dedication to his profession outside of the office is what separates John from so many others. He cares deeply about the future of our electrical industry as few others do today. So John, if you could come up. On behalf of the entire Electrical Installation Conference Board of Governors, it is my distinct honor and pleasure to present the 2011 Golden Omega Award to John W. Estey.
Don, thank you very much. I really appreciate this honor. And before dealing with the award itself, I would like to take a minute also to congratulate Nancy and the entire crew that has put this meeting together. You have done an excellent job. I've organized a lot of meetings, and you can tell a bad one from a good one, and this is better than a good one. I can tell you, when you serve on the IEEE board or the NEMA board, you deal with big picture stuff. It's pretty easy to lose track of where the action is, and this is where the action is. This is where the rubber meets the road. This is where the actual work is done. And you should be proud of the conference that you have. I actually had of course, you can't miss, I suppose you could say, because you take the combination of NEMA and one of IEEE's great societies and put them together. How could you not end up with a great conference? I was going through the papers earlier today, and I found, I was pretty impressed. I actually found a number that I thought were right up the alley of the kinds of things that we are working on right now. And I intend then to take them back to our chief installation wizard, who unfortunately couldn't be here. He said it was because he had a family conflict. I think the truth of the matter is he found out who the after dinner speaker was and decided he caught up on his rest enough. So congratulations on a great conference, Nancy, and all the rest who worked on it. It's a great tribute. This industry needs a lot of good meetings like this. Howard had earlier asked if it was okay to take pictures, and I said fine, but Howard had left out one thing. One guy who was one time introducing me, who had heard me speak before, said to the photographer, for heaven's sake, shoot him before he starts. You'll find out why. Anyway, it is very humbling to receive this prestigious honor. Frankly, I don't consider myself to be in the same league with former awardees, Admiral Rickover, David Packard, William Lear. I think I'm actually a little more in the category of the mule that was entered in the Kentucky Derby. A reporter asked the mule's owner, well, do you actually think the animal has a chance of winning? To which the owner replied, well, no, but I think the association will do him good. And I'm sure it will do me good to be associated with your prior recipients and with yourselves, and for that I thank you and the selection committee very, very much. I can tell you this is one of those moments that I really wish that my parents could have lived to share. My father would have really enjoyed the very generous things he said of me, Don, and my mother would have believed them. But I know the real reason I was concerned for this award is the accomplishments of my colleagues at S&C Electric Company, where there is a 100-year tradition of innovation that started with the two founders of the company, two engineers who worked for Chicago's electric utility, Commonwealth Edison. 100 years ago, they invented a really clever device called the liquid fuse. And since that time, S&C has been a source of inventions related to the field of electric power delivery. And it has been my great pleasure for the last 40 years, as Don mentioned, to work with many tremendously creative, talented, and motivated people at S&C. But you know, it wasn't just S&C that benefited from this sort of spirit of innovation. It was the same innovative drive that made this country great and has driven the growth of this economy for 2 centuries. I do fear, though, that this country is losing some of this spirit and curiosity that make innovation happen. And that's what I would like to talk with you about tonight as I receive this great honor. Now, I'm going to approach this from the perspective of the United States because this award is presented on behalf of the American people involved in science and industry. But I know there are people here from 26 different countries, and having grown up and worked in Canada, traveled to dozens of other countries, and spent a lot of time on this on the IEEE board, which is a very international organization,
I know that the things I'm going to talk about are just as applicable in most other countries in this world as they are to the US. Well, in 2005, a report titled Rising Above the Gathering Storm by the National Academy of Sciences warned that to keep the innovative edge, fundamental changes need to be made to the US K-12 education system, and that we must find ways to ignite passion among our citizens, particularly young people, in the areas of mathematics, science, and engineering. I wish I could say that things have gotten better since that 2005 report, but the 2010 follow-up report said the situation had actually gotten worse. A survey of global firms planning to invest in new R&D facilities found that a striking 77% plan to build in India or China. But these aren't assembly lines we're talking about. These are R&D centers. And no wonder. The World Economic Forum ranks the U.S. in 48th place globally in quality of mathematics and science education. In 2009, more than half of U.S. patents were awarded to non-U.S. companies. What to me is scary about this is the fact that while engineers and scientists represent only 4% of this nation's workforce, this group disproportionately creates jobs for the other 96%. So our ability or inability to grow new generations of innovators, from electrical engineers to technicians to developers of phone apps, will have a huge impact on the future health of this economy. I spent a lot of time thinking about this because we have hundreds of engineers and scientists at S&C, and we depend on them for our success. And I'll bet many of you have similar concerns from your own work, whether you're involved in industry, academia, or government. And I can tell you, this is a big issue on the minds of my colleagues on the board of NEMA. So I'd like to take a real-life example from the electric power industry to show the challenges that we face, and then offer some suggestions on the kinds of things we can do to address these issues as individuals and through our organizations. Think about that smartphone in your pocket. You did turn off the ringer, by the way, didn't you? Well, if we were able to bring back Alexander Graham Bell 135 years after he invented the telephone, he'd be astounded that people carry around these little things and can use them to call anyone, anywhere in the world, to look at anything on any subject that crosses their mind, and even keep our calendars and contacts in them. I'm sure you'd be really astounded to hear your phone play Eye of the Tiger instead of Ring Ring. My point is that today's telecommunication system is hugely advanced compared to the early days of telephones. Contrast that with the electric system that Thomas Edison, George Westinghouse, and others invented around the beginning of the 20th century. It pains me to say, but if Edison and Westinghouse were around, today they would both recognize and be absolutely comfortable with much of the technology that makes up today's grid. There's been little fundamental change in system design since that grid was first built. Fortunately, the digital revolution is finally arriving for electric utilities, and there are reasons to hope that the burgeoning smart grid will actually bring changes as far-reaching as what happened to telephones and the internet. By adding sensors, communications, and layered intelligence to what has been essentially a dumb electromechanical system, we'll have the opportunity to help solve some really important challenges. For instance, this smart grid can help reduce carbon emissions, improve reliability, enhance customer choice, facilitate the adoption of electric vehicles, and integrate renewable energy. McKinsey & Company has estimated the potential benefits to the U.S. economy from a fully developed smart grid to be $1.3 trillion. It will, however, take a lot of technical muscle to make those benefits happen. It is a big challenge because the technologies involved in the smart grid are really very embryonic. How we implement the grid and reap the benefits from it will depend in large part on the capabilities of our technical workforce. Getting the technologies right and scaling them up is going to require a lot of innovation on the part of the suppliers of equipment and software, as well as the electric utilities. This is no small task, as the electric grid is the largest machine ever created by mankind. And changing it in a way that is coordinated and safe while it's running is a major undertaking. It's kind of like the time that famed heart surgeon Dr. Michael DeBakey took his Mercedes to the garage for some work. Morris the mechanic was removing the cylinders from an engine in a car and called the doctor over. He said, "So, Mr. Fancy Doctor, look at this. I also open up hearts. I take out valves. I clean them. I put in new parts. And when I'm done, it purrs like a kitten. So, how come you get the big bucks when you and I are basically doing the same thing?" Dr. DeBakey leaned over and whispered to Morris, "Try it with the engine running." Well, that's our challenge with the smart grid. It's a big one. Now, some of you may remember when the Russians put Yuri Gagarin on the top of a rocket and shot him into Earth orbit in 1961. That was a great technical achievement, and it spurred President John Kennedy to set an even more ambitious goal. He said that the U.S. would invest heavily in the space program and would put a man on the moon and return him safely to Earth before the end of the decade. Well, he lit a fire of ambition and that spread across this country, inspiring tens of thousands to get involved in science and space travel. And by golly, in 1969, Neil Armstrong was standing on the moon. I think the implementation of this smart grid is going to take as much technology development as that moon mission, maybe more. But there's a big reason that it might not happen. It might not happen well in this and many other countries. This technological revolution is coming just as the electric utility industry is facing a demographic deficit, with nearly half of their technical staff approaching retirement age. This might not be so bad if there were a stream of high-quality engineers and scientists coming out of our schools ready and eager. But that pipeline just isn't there. And it won't be there in the future either if we don't increase the number of young people with a passion for math, science, and engineering. Now, S&C Electric is probably like most of the companies and organizations you represent. It is increasingly difficult for us to find the technical people that we need to keep our tradition of innovation growing and strong. And that's in spite of the fact that we've been working on this talent thing for decades. We have very strong ties with university engineering departments, run a very extensive cooperative education program, and do our best to nurture the new technical professionals when they hire on with us. And that's not enough to solve this problem. The only way that we will turn things around is if we get children excited and curious at a young age about how things work and how to solve problems. If we can do that, then we can fill up that talent pipeline and get this smart grid built along the way. So, how can we do this? Well, the Gathering Storm Report had some solid recommendations about the education system. We should certainly lengthen the school day and beef up our math and science and education, of course. But you know, it is always easy to talk about what others should do. I want to focus on what you and I can do, and what our companies and organizations can do, how we can contribute, and how we can make a difference. Now, I've got 5 ideas. These are small things, but I think they're just as important as the big structural changes that are needed, because they create a bridge between us in this room and the young people who could be tomorrow's innovators and inventors. And this won't be a small or token effort if we all, as a community of engineers, scientists, educators, and business people, all put our oars in the water in a coordinated way and pull together. So, here are my 5 ideas for your consideration. First, we have to support high-quality math and science education. You probably all remember a teacher who really turns you on about a subject. We need those kinds of teachers teaching math and science. But sadly, the reality is the majority of elementary science and math teachers don't have certification in the areas that they teach, which means they're not comfortable enough with the subject to get the students excited and learning. And we're doing something about that at our company. We've committed $500,000 over 5 years to a teacher education program at Chicago's Museum of Science and Industry. The museum brings in middle school teachers and puts them through a bunch of multi-day workshops, leading them through a series of hands-on, inquiry-based science projects that the teachers can use back in their classrooms. They build motors out of paper clips and magnets, knock eggs into glasses of water to demonstrate inertia, and they build hot air balloons. I've seen it, and the teachers love it. They get fired up about science and bring that enthusiasm with them back to the classroom. But does it make a difference? Well, the program has so far trained more than 700 teachers and sent them back to school with lesson plans and all the materials they need to do this work with their students. Those 700 teachers reach 26,000 students a year and 26,000 new students the year after. So yes, I do think this kind of thing can make a big difference. Number two, we should personally engage our youth and transfer our technical passion to them. In every community, there are science fairs, technology centers, museums, schools, and other venues where professionals like ourselves can interact with the youth. You know, when my daughter was 12 years old, she presented her findings on electromagnetic fields in the home at a school science fair. The attention she received there really boosted her interest in science. That experience and others came along, led her to study biology in college. It is a real conversation between a budding scientist and you or your colleagues that can make a big difference. And the kid could go away saying, you know, that person's an engineer or a scientist. Sounds pretty interesting what they do. I'd like to be one of those too. Well, there are plenty of opportunities beyond science fairs. At S&C, for instance, we support a physics program at a local high school. It's a small grant, but as part of the commitment, we bring the students into our engineering department so that they can see the variety of rewarding jobs that our technical people do, which they like. We also support the after-school program, which had them building and shooting off a model rocket. They like that too. My point is, we only have a short window in the lives of these kids to reach them. You have the knowledge, you have the passion, and you know others that also do. All of you together can light the fires of curiosity. You can turn a kid into a technical problem solver who lies in bed figuring out how to make things work. Third, we should help youth get involved with hands-on projects. One of my regrets with today's society is that young people don't have the opportunity to spend as much time as they used to with tools in their hands. Young people used to work on cars and make them into hot rods. Today, most products are built in such a way that they discourage you from being able to take them apart. However, there is actually a really great opportunity to get them involved in hands-on science in a way that appeals to kids of all sorts, and that's robotics. An excellent program that's easy to get engaged in is called FIRST Robotics. It was actually founded in 1989 by a previous Golden Omega recipient, Dean Kamen. That program now reaches 250,000 students a year and 22,000 robotics teams. FIRST Robotics puts tools and equipment in the hands of children as young as 6 years old. The high school competitions are quite elaborate, demanding skills in mechanics, optics, communications, programming, and of course, integrating all that in a machine that actually works. We make a small grant each year to support a FIRST Robotics team at a local high school. A number of our engineers help them out, and in the process, connect with those kids and give them a sense of what engineering is all about. Number 4, though this may pain some of you, we need to bust up the old stereotype of geeky engineers and mad scientists. Let's face it, we've had a lousy image for a long time. Movies have long portrayed scientists as evil lunatics. And even when we're the good guys, the films often get the science wrong or oversimplify it. We don't do much better out in the real world, where we're still saddled with the stereotype of socially maladjusted loners with pocket protectors, not quite sure how to dress and talk to others. But there's actually some very encouraging activity in this front. A number of recent films have depicted scientists as the heroes. As television shows like CSI showcase young and attractive people in jobs as forensic scientists. And these role models have had an impact on the types of careers that young people see themselves going into. Beyond this, and this is important, we need to emphasize how engineers and scientists help make this planet better, and how we can improve everybody's quality of life. Take, for example, the role of the smart grid in cutting carbon emissions, or keeping the electrons flowing to critical electric loads. Or consider MRI machines that can can see what's going on inside of us without the need for expensive and painful surgery. There are thousands of examples of how scientists and engineers help society, and we can all do our part to highlight that feature of our profession. And I believe this is a message that will certainly resonate with and appeal to today's youth. Today's young people are looking to help save the world. Finally, we need to expose our youth to important challenges that they can use to develop their skills. I believe a single encounter with an inspiring person can sometimes change a kid's trajectory. But more often, it's a sustained and challenging project that will help someone discover their problem-solving gene. That's why we support a program run by the Adler Planetarium with the Air Force Academy High School. The PhD works with the students in the school, at the planetarium, and in an after-school program. Some students work at the planetarium in the summertime and they describe science to the museum's visitors. The students in the after-school program recently built a very sophisticated, remotely operated vehicle whose task was to go underwater to a valve and turn it off. Kind of like as if there was a leak in oil in the Gulf of Mexico. Our team won that local competition, and next week they'll be competing for the national prize at NASA's Neutral Buoyancy Lab in Houston. In my view, that is exactly the kind of challenging and stimulating experience that will turn kids on to science or engineering and ultimately help us fill that talent pipeline. Well, is overcoming this deficit in math, science, and engineering capability going to be easy? Obviously, I don't think it will be. I think fixing this is a 10 to 20-year undertaking. Cannot be done overnight. And it will take structural changes in our education system and economy that most of us aren't likely to get too involved with. But there isn't one of us here who couldn't make important contributions to that effort. We cannot leave it to the government or to others to solve this problem for us. I think we should get involved individually, personally, and encourage our colleagues to get out there in an all hands on deck, every day of the week effort to try and raise the position of science and engineering to what it should be, one of great importance as society faces huge technological issues. And though we will have to invest real resources to solve this problem, it isn't really a financial challenge. As Nobel laureate Sir Ernest Rutherford once said, "Gentlemen, we have run out of money. It's time to start thinking." As I said earlier, I've been thinking about this for a long time, and I believe we can rekindle that spirit that leads to innovation and a better world. We're trying to do our part at S&C, and I'm convinced, confident that many here are making similar commitments and are already prepared to do more. We can make a big difference in the future, and that's a good thing for all of us because, as the fabled head of research at GM, Charles Kettering, once said, the future is where we'll spend the rest of our lives. And who knows, one of the young people that we reach may someday be standing on a podium like this, feeling just as proud as I am. On behalf of the skilled and talented colleagues that I have at S&C, I would again like to thank you for this honor. I truly appreciate it and your very kind attention tonight. Thank you.